Number 3 is the first one I would really call algebra. You have an equation, v equals d over t, and you want to solve for t. In other words, you want to rearrange it, get to a different equation where t is by itself and figure out whatever goes on the other side. One of the things that people, I think, have trouble with in math is that there's actually a lot of freedom. The rules for rearranging equations are pretty open-ended. There's a lot of possibilities. Basically, the rule for changing equations around is you can do pretty much anything at all to the equation as long as you do the same thing to both sides simultaneously. We talked about how you can always multiply by 1. You can't multiply things by 2 without changing them, but you can certainly multiply by 2 on both sides. So you can multiply both sides by 2. If this is a legal equation, and then this is fine too. You can add 7 to both sides. You can square both sides. You can do all kinds of things. As long as you do the same thing to both sides, you're still looking at a valid equation. None of these are doing us any good, though. They're not getting us any closer to kind of this form here. I mean, we need to move the letters around, so we need something else. One way to look at it is just kind of what's wrong with this compared to that. I mean, a couple of things. We want t by itself and in the numerator. Here this t has a d over it, and it's also in the bottom of a fraction. So I'd like to undo both of those. There's more than one path that'll get you there, but let's go ahead and get the t out of the denominator first. We want to have a t that's not in a fraction. Trick for doing that to kind of get this to move letters around is to, well, if we multiply both sides by t, so when you get to algebra, they'll start using a dot for multiplication because the x or the multiplication sign can get confused with x's, which they're these letters stand for different numbers, and x is one of the ones they use. So multiply both sides by t. That actually does something for us. It basically moves the t over here. This is t over t. T pi's divided t ways is 1, regardless of how big t is. So that gives you that there. Now, if you prefer, you could think of this as a t over 1. That's fine too. That's actually another one for our list. We have that small list of things that have no effect in mathematics. You can always multiply by a 1. You can always add a 0. You can always divide by 1. Or in other words, that's the same as having a fraction over 1. So a fraction over 1 is always an option. If you want to see the fractional form with an over 1 in there, you can always put it in there. If anywhere in a problem, you can always put it over 1. If you get tired of looking at it, you can always take it back out again. So anyway, we've made some progress. T is no longer in the bottom of a fraction, but it's got this v multiplied by it, so we'd like to get rid of that. Well, the way to get rid of a multiplied v is to divide by it. So divide both sides of this by v. Now you can start to see how these things are kind of interrelating a little bit. I said the words, divide by v, but I didn't. I didn't do that. I didn't do the division sign. I wrote a fraction bar and put a v down there. But again, the fraction bar is just another way of showing division. So this is dividing by v. What that does for us, though, is you can see that v over v, again, that's v pi's divided by v people. That's 1, regardless of how big v is. So that just gives you t times 1. Or again, times 1 has no effect. It can be dropped. So you're just left with a t. So d over v is what you should have had. should have had for that. This right here is why when you get to algebra, they basically quit using the division sign. The division sign was something you saw, all through elementary school and maybe even junior high. But at some point, they just kind of like quit using it. You don't have to. I mean, we can divide both sides by v here. But the thing about the fraction format is it's nice. It's easy to see variables kind of canceling out. I mean, how do you actually perform this? Well, this is vt divided up v ways, so it goes in t times, I guess, with a remainder of 0. I mean, you can't do it that way, I suppose, but that gets messy. And if there's a remainder, you've got trouble. So that's why when you kind of get to algebra, they drop the division sign and start writing things as fractions always.